So our next unit is measures of center and spread. The three measures of center that we're going to be looking at are mean, median, and mode. The mean is the average of all the data values. You add them all up and divide by the total number of data values. The mean is a good representation for the measure of center to use when the data is very similar. The median is the middle number when the data set is organized numerically, meaning smallest data value to largest data value. And this is a good measure of center to use when the data set is either varied or has an outlier. The mode is the data value that occurs most often, and you'll want to use this when the data is not numeric or you're just interested in the most popular answer. The mode technically is not really a measure of center because the mode doesn't necessarily occur in the middle of the data set. An outlier is a data value that's a lot larger or a lot smaller than the other data, so it doesn't really fit in with the rest of the data set. And then the measure of spread we're going to be looking at is the range, and this is when you take the greatest data value and you subtract the smallest data value. So our objective today is to analyze data using measures of center and spread. So our first example is we have some phone bills from January through June, and we're going to calculate mean, median, and mode. So first, mean, remember, is the average. So we will add all of the data values. And divide by 6 because there are 6 data values. And this gives us an average phone bill of $35. The median, when you line up the data values in order, will be the middle data value. So our smallest data value is 29, and then we have 31, and 32, and two 35s, and 48. So when we look for the middle data value, when your data set has an even number of data values, you find the average of the middle two data values. So we're going to take a look at 32 and 35, and halfway between 32 and 35 is 33 and a half. So our median is $33.50 if we're going to make it make sense with what the data represents, which is money. And then finally, the mode is the number that occurs most often. So the mode of our data set is 35. We had two bills that were both $35 each. So now we're going to take a look at which value do we think best represents the data set and why. Now remember, the mode isn't exactly a measure of center. We do have two data values, the mean and the mode, that are both $35, and the median is $33.50. When I look at this data set, the bills from $29 through $35 are pretty similar to each other, and then that $48 bill is quite a bit larger. So I'm thinking that because we have a data value that doesn't really fit the rest of the data set, that the median is the best representation of the center. Alright, so next we're going to calculate the range. The range, remember, is the largest data value, which was 48, minus the smallest data value, which was 29. So that gives us a $19 range. So what this tells us when we're talking about phone bills, $19 seems to be a pretty big spread between the phone bills. So I would say the data set is varied. Now there's no set number that means it's a large range versus a small range because you have to interpret it in terms of what the data represents. And then D, any outliers, and we did talk about that $48 was quite a bit larger than the rest of the data set. And we noticed the impact on the mean was greater. That's why we chose the median as the better measure of center, as well as the range was quite a bit greater because if the $48 wasn't there, the range would have been 35 minus 29, which would have only been a $6 range. So that outlier changed the range quite a bit. And the last thing we're going to take a look at is displaying data. So our first display is a stem and leaf plot, and we're actually going to take a look at a back-to-back stem and leaf plot. So what I did to save us a little bit of time was I filled out half the stem and leaf plot for the first hour, and then we'll go through how we set that up looking at the fourth hour. So the stem and leaf plot, what it does is it takes the first digit in your number and it puts it as a stem. So those are the numbers that I have in the middle, in between my two bars. So what they represent are 40, 50, 60, 70, 80, and 90 when we're looking at our test scores. It's the first digit in our test scores. And then the numbers to the left of the bar represent the leaves, or the second digit in our numbers. And you have to put them in order, and also notice how they're spaced evenly. So even though 1 is a skinny digit, I still have that next data value, that 8 that's next to it, spread out quite a bit. So if we look through this, I'm gonna underline it quick, right here represents the data value of 42 from the first hour class. And then the next leaf is an 8 that also goes with the 4, so that represents the 48. So we're gonna take a look at, clear those out of there. We're gonna take a look at creating that stem and leaf plot with the fourth hour. So what we have to do is look at them in order, and as I'm looking through, I don't see any data values that are 40 in the 40%. So I am going to start with 53, and I don't see any other data values in the 50s, so we're gonna put a 3 next to the stem of 5. And then the next smallest data value I see is a 67, and I don't see any other data values in the 60s, so I'm gonna put a 7 for my leaf. And then I notice 2 78s and no other data values in the 70s, so I'm gonna put an 8 and an 8, and I'm gonna try and spread them out about the same amount that I did on the left side of my stem and leaf plot. And then for the 80s, I have an 81, and again, remember, you're gonna try and spread that out a little bit more because it's a skinnier number. And then 84, and try and line it up with the 8 right above it, and 88. And then for the 90s, I have 95, 96, and 99. And with every stem and leaf plot, you need a key. And in this case, because it's a back-to-back stem and leaf plot, we need 2 keys. So over here, I'm gonna tell people how to read my stem and leaf plot. So you choose any stem and you put it in between the bars. Choose any leaf, and then we let people know that represents 67. Because it could represent 6,700, it could represent 0.67. There's lots of different ways to use the stem and leaf plot. So then on the other side, what we have to do is write the leaf first, because we read left to right. So I'm gonna choose my leaf of 9, and make sure you put the stem between both bars so people know that that is the way that they're reading it. And then this represents the number 59. Alright, so the last thing we're going to do is compare the shapes of the plots. And this gives us some information about the data. So as we're looking through, on the first hour, I see 3 data values in the lower 2 stems, and only 1 data value in the lower stem for the fourth hour. And then for the higher 3 stems, I'm seeing a lot more on the fourth hour side than I do on the first hour side. So I notice that overall, first hour probably has a lower mean and median. And fourth hour performed better on average.